Previously on Carbohydrate Lecture, we discussed the aldoses. These were trioses, tetroses, pentoses, hexoses, mainly. And we began to break down this flow chart. We started with the simplest carbohydrate at the top, and we added a carbon, and we talked about the D versions only, and how these C2 epimers began to exist, and that gave us different carbohydrates. We then added another carbon to get 5 carbons, and then we added another carbon to get 6 carbons. And we went through this flow chart, and we talked about these aldoses and which structures you should memorize. The same thing holds true for the ketoses. So we have aldoses and ketoses, and these keto groups have a ketone in them, right? So that's a C double bond O somewhere in the middle. And traditionally, this C double bond O happens on the second carbon in. So here's my keto group, here's the keto group, second carbon in, keto, second carbon in, keto. All of these second carbon in have a C double bond O structure, right? Okay, so that's one of the trends that happen with these ketoses. Now this chart, just like the previous one, can also be found in the text. It's in the Carbohydrate chapter. If you're working out of the 7th edition, you're going to find these charts on like 1021 and 1022. That's with the 7th edition. If a newer or older edition you're working out of, it's probably somewhere near that, but you'll find it in the Carbohydrate chapter. All right, we do the same story with the ketoses. There's really no difference here, right? We start off with the simplest ketose that we can find. CH2OH at the top, CH2OH at the bottom, and we see a C double bond O group here. This is called dihydroxyacetone. You can kind of see why they call it that. Acetone typically is a C double bond O with a CH3 group there and a CH3 group here. One of the hydrogens have been removed. OH has been replaced with that. So di means 2, hydroxy means OH. I find an OH group there and an OH group here. So dihydroxyacetone. All right, well, if we extend the carbon chain, we finally get a molecule that has some stereochemistry now. CH2OH at the top, CH2OH at the bottom, ketone on the second carbon, and I've got this chiral center right there, and that OH group is on the right-hand side, so therefore this is a D sugar. Well, what is this sugar called? Common name that we use is erythrulose. So these ketones are not only uglier as far as structure goes, but they're uglier as far as the name goes as well. That's kind of a weird name, erythrulose, right? Okay, so if we extend the carbon chain again, well, here this top piece stays the same. CH2OH and C double bond O, right? CH2OH, C double bond O. We add another carbon into the chain. So that choice could put my OH group to the right, or that choice could put my OH group to the left. Depending on where it goes, I get a different ketose. This one is D-ribulose, and this one is D-xylulose. All right, so once again, D, last OH group, D, last OH group. Well, from ribulose, I could add another carbon, and this carbon I have a choice. The OH group could go right-handed, or it could go left-handed. And depending on where it goes, I get psychose and fructose. And then xylulose is the same. I add another carbon. That OH group could go right-handed. That OH group could go left-handed. And from this, I get sorbose and tagatose. So D-sorbose, D-tagatose, D-fructose, and D-psychose. Out of all of these structures, the good news, and you will jump for joy when I say that only one of these structures you need to memorize, and of course that's the one with the box around it, and that is fructose. That's the only one that you need to memorize out of the ketose family. Fructose is one of those common sugars, yet again, that we see all of the time. Fructose, of course, is fruit sugar. So when we talk about fructose, it is a biologically active, commonly found sugar out there that we run across on a daily basis all the time. So one out of the ketone family, and then you've got around 6 out of the aldehyde family. So make sure that you understand what these structures are. Make sure that on the test, because I'm telling you now, the first page of the test is going to be draw the following sugars. And I will list them, and you will go through and you will draw those structures that I ask for. And all of them will be listed. Your erythrose, your threose, your glyceraldehyde, your glucose, galactose, mannose, and fructose. All 7 of those will be on the sheet of paper, and that will be your first objective. So make sure that you can draw those structures. Don't lose out on those easy points, because I'm telling you now that will show up on the test. So take advantage of it. Take advantage of the information. I'm giving you that information for a reason. I want you to do good on the test. I want you to pass the course. So make sure that you understand how to draw these structures, and you'll be okay. Alright, so that's all that we need to talk about the flowcharts. Now we're going to come back and we're going to look at a couple of questions. Now that we know where to find the names of these structures and the actual structures themselves, now we can go in and start modifying these questions. So for instance, what sugar is the C2 epimer of this sugar? So we can use these flow charts to kind of help us out with that information. So that's what we're going to do in the next video. It's going to be more example problems, but these will be a little bit more specific. And you're going to see these on the assignments, you're going to see them on the quizzes, and you'll see them on the test as well. So again, stay tuned. Don't stop yet. You're almost finished with kind of this section of the lecture. So look at the example problems, work out some of these example problems, make sure that you feel okay with them before moving on.